this is Lori with STEM Excellence Tutoring. Today I'm going to talk about equilibrium constants and how we can use them in acids and bases. So, just a reminder, an equilibrium constant when you have a reaction is the products raised to their coefficients over the reactants raised to their coefficients. And it can tell us where in a reaction an equilibrium is favorable, whether it's product favored, or the equilibrium constant value is greater than 1, or it's reactant favored, or the equilibrium constant value is less than 1. In general, for weak acids and bases, the base analog is going to be the same for everything I talk about. For weak acids and bases, the K value is going to be less than 1. That means all weak acids and all weak bases are reactant favored. That's a property of being a weak acid or a weak base. So let's look at some examples. Let's consider this reaction for acetic acid in water. The Ka expression is going to be the products over the reactant. Remember, in our equilibrium constant, we don't put solids and liquids. So since water is always a liquid, it doesn't go in our expression. The Ka value for acetic acid is 1.8 times 10 to the negative fifth. These values are very well known, very well established. If we compare that to nitrous acid, the Ka expression is going to again be the products over the reactant. And this value is 7.2 times 10 to the negative fourth. Well, this value is greater than this value. So this tells us that this reaction for nitrous acid is less reactant favored than this reaction for acetic acid. Because it's less reactant favored, that tells us that nitrous acid is a stronger acid than acetic acid. So in general, the trend that you can remember is the greater the Ka value or the greater the Kb value, the stronger the acid or the stronger the base.